Not today. We missed a lot, man. All right. So what do you guys? So this shifts right 1. Does that make sense when I say that? It shifts it to the right 1. I really want this to make sense. In order to have the same answers that it had before I put that there, my inputs have to be 1 bigger than they used to be. Because the first thing I do to the poor thing is take 1 away from it. So I used to put 0 in to get 0. Now I've got to put 1 in to get 0. That's why it does the opposite of what it looks like. You don't look at this and say it goes back 1. You say, what does it have to do to overcome this? It's got to go up 1. Maybe. And this idea, by the way, works. I don't care what function you got. The square root of x looks like this. Remember this? We've done this before. 1, 1, 4, 2, right? That's the square root of x. So what does the square root of x plus 2 look like? It would go back 2 and go bam, right? I could make it more precise, but you get the idea. That would move back 2. So it doesn't care what the function is. If I put it in with the x, it's going to move left or right. If I put it outside, it's going to move up or down. Is that simple? Is that straightforward? Because what does that do? It takes all the outputs, makes them 1 bigger, so the whole damn thing would lift up in the air. Yeehaw. Okay, all right. So what's the point of all this shit, Jeff? You started with a vertex and went crazy. Well, where's the vertex now for this? Where's the vertex? 1, comma 0. Oh, vertex is a point. I like it. You got to give me a point. So see if we can put this all together. Oh shit. So where is the vertex? Wherefore art thou, vertex? For this here. You put it all together in one thing. What would that piece do? Take it down 5. So I know the vertex is at -5. Good. And this, what's the opposite of, what makes that 0? -3. This is neat. That's why this is called the vertex form. Some books call it the standard form of a parabola. But I want you to understand, for a line, if I put it in this form, I know a lot of shit about it. For a parabola, if I put it in this form, I know a lot of shit about it. In fact, it looks like I only know the vertex. But how did I know it was like this? Because it's positive, right? If there was a negative here, it would have been going down. Okay, I like it maybe. Roughly related to slope in a kind of way. Okay, maybe. All right, I got more of you looking like you actually get that. Okay, good. Maybe it's the room. You guys feel like you could share more in here. I don't know. The other room, you guys were poker professionals. Okay. I'm not joking. You make a lot of money if you play in that room. All right. Oh, so here's the standard form of a parabola. In all of its glory. Let me put it in function notation even. Ooh. For some reason, we always use H and K when we're talking about vertex or center of a circle. You'll see the circle equation. We're going to do that. It's one of the last things we're going to do. The equation of a circle is going to have an H and a K in it, and that's going to be the center of the circle. So I can move the circle around by changing H and K. I can move the parabola around by changing H and K. So the vertex of this is HK. And if A is greater than 0, it opens up. If A is less than 0, it opens down. What about if A equals 0?
It's equal to 0.
Thank you, Yogi Bear. That reference is way too old for you. Yogi Bear was famous for this kind of thing. If A is 0, then I get Y equals K. I get a straight line. Straight line. Kind of makes sense. Can you imagine? Now think about it. If greater than 0 is this, and then it gets less, it gets closer and closer to 0, it gets fat. That's one thing I didn't tell you guys. But if it's like 1/2, 1/4, it gets fat. And then at less than 0 gets to be down here. So what's it in the middle? It's got to be a straight line. So at 0, it becomes like 7 or something. It just becomes a straight line. That's the middle of taking it from up here, straighten it out, straight line, keep going, now it's down there. That's kind of neat, that progression. All right. Okay. Maybe. Okay, so you're gonna love this. You should be scared when I say that. So a couple things. Let me see which way to go with this. Is this in standard form? Does that look like that? No. We have a process that we learned today that would help me put it in that form, because this is a square. So I have a process that will help me complete the square. Oh, you guys are gonna love this shit. So watch. Now here's the bad part about this. There's not really two sides to this. There's a function is this. There aren't two sides. So what does that mean for me? I don't know. I gotta move the 5 over there. Make some room. It's the same old process though. In fact, some of you guys might even remember the number. How do I get there? How do I get this number? Cut 6 in half, and then you square it. So I need to, what do I need to do here? If I add 9, how do I do something else that makes me have done nothing? So overall, what did I just do? Nothing. So that's why it's legal. Now normally I'd add 9 to both sides. This is not really a side. This is just the name of a function. I really want to, I always think about Indiana Jones. Has everybody seen Indiana Jones and the Raiders of the Lost Ark? If you haven't, do that immediately. But some of you guys, if you haven't even seen, you've seen the part where he takes the gold idol off and he puts the bag of sand there, and he's obviously made a mistake because the stupid boulder comes after him. So he didn't really balance his equation that well. Oh, Jeff. Sorry. But that's basically what's happening. If I take the gold statue away, I better add the same amount back in. So overall, I did nothing. So the boulder's happy, and as happy as a boulder can be, and it doesn't feel like smushing me. So that's me adding in the sand, and that's me trying to take away the golden idol and get the hell out of there and put it in a museum. Nobody Indiana Jones? All right, I'll be all right. So what's this? All right, sorry. When I do that shit, it's like math. Can we get back to the math?
There's an equal between 9 and 5, right?
There's a who what? No, there's an equal right there. There can't be more than one equals in any function statement.
So in this case, we add 2 places, 2 more.
No, I didn't. I added 9 and subtracted 9.
You added 0.
So doesn't this still become this? Yes, it does. Right? So I did not change this, which is what anything I do cannot change what's there. So if I add 9 to both sides, that doesn't change what's there because the equality is still the same. But if I'm only allowed to work on one side, whatever I do, I have to at the same time undo it. That's what makes it legal. And real quick, if I add 9 to both sides like I'm not supposed to, can't I subtract 9 from both sides? There you go. You really need that step in there, right? But how can I write this now? So what's the vertex?
-3.
All right. Maybe.